Alright guys, welcome to this page of the notes, and here's what we're going to do. We're going to begin to take a look at that first objective or learning target, which is discussing the properties of logarithms that are going to allow us to simplify logarithmic equations into something that we can then use the property of the equality property of logarithms to then help us solve it. Alright. Again, the reason that these properties of logarithms work is because of what I just stated on the previous page. Logarithms are exponents, right? A logarithm is an exponent. So, several of the properties of exponents that we have learned in a previous chapter can also be applied to logarithms, because a logarithm is an exponent. Remember, I showed you right back here on the previous page, I made a big deal about it. Remember? Y, the exponent, y by definition is the logarithm, right? So logarithms are just exponents. And what we're going to do here is, because logarithms are exponents, we're going to use a couple of properties that you should recognize, properties of exponents that will now apply to logarithms. All right, first of all, these properties of exponents right here, if you don't recognize them, or you've not seen them before, those of you taking this class with me, obviously you've seen them before, but if you don't recognize them, just go on back to Chapter 5, Section 1. Chapter 5, Section 1, I'll review all of the properties of exponents, not just these three. We go over all of them. So it might actually be a good review if you wanted to go back and just quickly refresh your memory on the properties of exponents. But if you recognize these three properties of exponents, I'll just show you how they now apply to logarithms, and then we'll jump into actually using them. All right, the first one I've got for you is the product property of exponents. And I apologize, I actually have a slight typo on here. Give me a second to fix it. So this is the product property, and if you remember your properties of logarithms, you'll recognize I've written this one incorrectly. Actually, it should be written as a to the m times a to the n, right? And the way the property works, it's called the product property because if you multiply like bases, right? If the bases are the same and you have multiplication, then you add the exponents. So that's why it's a to the m plus n, right? So this is the product property of exponents, and as long as the bases are the same, I would then add the exponents. The second one is going to be the quotient property. So the quotient property of exponents, this one's written correctly. If I have a to the m divided by a to the n, again, the bases have to be the same, right? A and a. It's a constant, it's a number, 2 and 2, 3 and 3, 4 and 4, whatever. Pick your favorite number, but a and a. As long as the bases are the same, if we have division, you'll subtract the exponent. So you should remember that property. And then we've got this one, the power property. We've actually used this power property quite a bit in this chapter already. We used the power property back when we were solving exponential equations, and we saw this power property quite a bit. Anytime you have a power of a power, right, you multiply the exponents. So here's how these properties of exponents apply to logarithms, which logarithms are also an exponent. That's why these properties apply, and here they are. The product property for logarithms. Well, if you have the logarithm, actually, real quick before I jump into these any further, these are equals, right? It's an equation, which means that the symmetric property applies, and they can be written in either direction. In fact, let me go ahead and do that. These can be written either way, and you will be expected to be able to go back and forth between the two forms, right? It doesn't matter. Oh, sorry, I wrote min, and it's not min, it's m times n. Right? Whether I give you the logarithm base b of the product of something, and you split it up into addition, which makes perfect sense, right? If they're multiplied, then you add the exponents, right? So if they're multiplied, you add the exponents, or if the exponents are added, then you would multiply them by the same base, right? Same base a times a, right? A and a, same base. Then you add the exponents. I have the same base. They're multiplied, so you would add the exponents, right? Or if I give you this and ask you to go the other direction, you need to be able to go both ways, and we'll do several example problems. So that's the product property of exponents applied to logarithms, and actually you can see now, if I go back to the previous page, I sort of started this discussion by saying this is the problem that we have and we need to fix, right? I have this property that has the log base b of x equals the log base b of y, and as long as it's a log base equals a log base, I can set the arguments equal to each other. But what happens if I insert addition or subtraction in there? The property doesn't apply unless we can simplify this guy. And we just found out how, right? I've got the addition, log base b of m plus log base b of n. That can be rewritten as multiplication. So if I go back here, what you guys can quickly see before I move on to the next ones is because I have addition right there, right, and the log bases are the same, it can be rewritten as the log base 2, right, of x times 4x, right? I would just multiply those arguments together, equals the log base 2 of x minus 3, and just like that, now my property applies. I have log base 2 of this product equals log base 2 of that product. All I have to do, sorry, product, it's a difference. All I have to do now is set my arguments equal to each other, right? So that's how these properties of logarithms are going to be really, really important in doing what we're going to do here in this section. Again, we have the quotient property of exponents. To apply it to logarithms, again, you need to be able to go both ways. Doesn't matter which way, give it to you. Log base b of m minus log base b of n would be equal to the log base b of m over n. It's always going to be the top minus the bottom, So if you were given a quotient, the logarithm of a quotient, and you were asked to split them up, the numerator comes first, and then it's minus the denominator, top minus the bottom. Or if you're given, a subtraction, you're asked to condense it, which is what we'll probably start with. You can just write it as a quotient. And then finally, this last one down here is the power property of exponents, which will apply to logarithms. Again, you need to be able to go both directions, so n times the log base b of m is equal to the log base b of m to the n power. It's just going to be a constant, right? Some constant multiplied in front of the logarithm. If you ever have a constant out in front of the logarithm, it just becomes the power, right, of your argument. Or vice versa. If you've got an argument with a power, you can just simply bring that constant, that exponent, drop it out front and multiply it as a coefficient. All right, so those are the properties of logarithms. Again, they come from properties of exponents, and we can do that because a logarithm is an exponent. So it should be very simple properties. Certainly, hopefully you see the correlation between what we did back in chapter 5 and now applying it to logarithms. Let's go ahead and take a look at how these are going to work in an example problem. So I've got this one here for you. I want you to solve for x. There's my x right there. And I know that I'm going to need to use the equality property of logarithms, which says if log base b of x is equal to log base b of y, if and only if x is equal to y, right? So this is my equality property of logarithms, and I'm going to set my arguments equal to each other and solve for my variable as long as I have a log base b and log base b on both sides, as long as the log and the base are the same. But I don't have that, right? I've got this subtraction sign in here, right? So I have 3 times the log base 5 of x minus log base 5 of 4 is equal to the log base 5 of 16. So this property doesn't apply the way the equation that I've given you is written. So we'll need to simplify. And again, it's just up above, but it's subtraction. So immediately you should think, I'm going to wind up with a quotient. But before I do that, careful, I've got this coefficient out front. So I'm going to go ahead and make that coefficient a power first using the power property. So I'm going to start by using the power property to bring this 3 to an exponent position, right? That number out front just becomes the exponent. And then the subtraction I'll convert into a quotient using the quotient property of exponents. So here we go. That's a quick description of how this is going to look. Now let's go ahead and do it. So here's what I've got. I've got 3 log base 5 of x minus log base 5 of 4 equals log base 5 of 16. I can rewrite this. That 3 becomes the exponent thanks to the power property. So log base 5 of x to the third minus log base 5 of 4 equals log base 5 of 16. Now I can use the quotient property because I have subtraction to write a quotient. It'll be x to the third divided by 4. So log base 5 of x to the third divided by 4 equals log base 5 of 16. Perfect. Now what I've done is using those properties of logarithms, I've simplified it to the point now where my equality property of logarithms now works. I have a log base b of an argument equals a log base b of another argument, log base 5, set the arguments equal to each other and solve for x. All right, so here we go. I know that then x to the third divided by 4 is equal to 16. Multiply the 4 to the other side. I get x to the third. I got a calculator here. 16 times 4 is 64. And then to get the x by itself, right? Well, we know this from the previous chapter because it's cubed. I'll take a cubed root of both sides. Algebra says whatever you do to one side, you got to do to both sides. And as long as the index and the power are the same, they'll cancel each other out. That leaves me with an x. And the cubed root of 64 actually turns out to be 4. All right, now what you're going to need to do, right, remember you cannot take the logarithm of 0 or a negative number. 0 or a negative number. So you will need to check your solution, right? So let me go all the way back up here to my previous problem, or the original problem. I got x equals 4. If I plug a 4 in here, no problem. I can take log base 5 of 4. That's the only place I have an x, so it works out. And so our solution checks out. We're good. All right, guys, that's the way these problems are going to work. We're going to use those properties to simplify down these equations so that I can then use the equality property of logarithms to solve for the variable. Head on over to the next page of the notes. We'll try a few more of these. I'll meet you guys there.